VXLAN, Virtual Extendable Local Area Network. It's a tunneling technology, tunneling technique like OTV. The previous topic that we saw is OTV. VXLAN was initially using a port number, and that port number is the same port number given for OTV. And the port number is this one, 8472. This was the port number according to the old standard of VXLAN. OTV and VXLAN were using same port number. Later, IANA has changed it to 4789. So, when you do some sniffing of VXLAN traffic, you may sometimes see this one as a port number. So you should not wonder why it is 8472. Both can be seen in the packets. But currently this is what? The registered port number for VXLAN. 4789. Easy to remember. You see 4789. 4789. This one is 8. Half of 8 is 2. And 72. OTV. Even today, even now, OTV is 8472. UDP 8472. Earlier it was also for VXLAN, but now it is 4789 UDP. So we create a UDP, a negotiated tunnel between the VTAPs, which is nothing but the edge device to which the sites are connected, remote sites are connected. The edge devices to which the remote sites are connected. See, this VXLAN is not only in data center, it is also in service provider and enterprises. That is why I'm using the word site. In data center, we try to use leaf and spine architecture. So VXLAN tunnel endpoints are leaf. VXLAN tunnel endpoints are leaf. But in ISP, in service provider, when you use VXLAN, they are PE devices. VXLAN tunnel endpoints are provider edge devices between provider edges. Along with the MPLS, I have seen VXLAN along with MPLS. Instead of EVPN, service provider will use MPLS as a data plane transport. When MPLS is the data plane transport, labels are going to be used, not the IP address. When we do EVPN with VXLAN, IP address is going to be used, not the labels. So in data center, we use EVPN, not MPLS labels. VXLAN with EVPN. The control plane is EVPN for the data plane VXLAN. So control plane can be MPLS, can also be EVPN. Now, let's go back. As I told you, a tunnel is established. You see, these two belong to same VLAN. But they are not connected to same switch. And I want this 10001 to talk to this 10002 through tunnel VXLAN. What is the advantage? I can make use of this layer 3 advantage, layer 3 benefits in a layer 2 level. What do I mean by that? When I have layer 2 instead of layer 3, these links all will not be active. Some will be blocking. As a result, I am losing half of my resource, half of my bandwidth. When I have layer 3 with /31, that is enough. /31 is enough, or /30 on these links. It will be non-blocking port. All these will be layer 3, and all these links are layer 3. There won't be any block anywhere. No blocks. No block anywhere. See, that's the advantage of layer 3. So what we are trying to do is, we are going to have a layer 3 transport in the middle, over which we are going to negotiate a layer 2 tunnel. So this, which is in VLAN 512, is extended to the remote leaf, remote VTAP, virtual tunnel endpoint. Layer 2 extension over layer 3. With the help of UDP, this is negotiated. This is like MAC in UDP /IP. It's not TCP IP. It's not TCP /IP. It is UDP /IP. MAC in UDP /IP. With the help of UDP, you are able to negotiate tunnels. Once the tunnel is up, you are able to do layer 2 communication. So this VXLAN provides this tunnel. How VXLAN running on this VTAP1 knows the remote tunnel endpoint? That's the next question. If tunnel is formed between VTAP1 and VTAP2, how this VTAP1 and VTAP2 knows that VLAN 512 is connected and we need to form tunnel? See, VLAN 512 is not here. It is 1512, different VLAN. So the tunnel is not coming up to VTAP3. The tunnel is only between these two VTAPs where the VLAN 512 is. How VTAP1 and VTAP2 knows that they have to form tunnel? Or in another word, how VTAP1 knows with which VTAP I should negotiate and form tunnel so that that will be the tunnel destination. That is what here I'm going to begin this class with. The packet forwarding engine makes its forwarding decision by referring into the forwarding table. This is well-known story for everyone. How a switch forwards the packet? Forwarding table will tell on which port the packet should exit. You have forwarding table on switch, on router. So they tell the exit interface, they tell the destination port. But in VXLAN, how is this forwarding table built? In a normal switch, all the ports are on the same switch. So we understand how the forwarding table is built. But here, the destination port is not on the same VTAP1. It is on VTAP2. It's a different switch. So how VXLAN knows that the exit port is on VTAP2? I have to go and negotiate a tunnel. For that, it is taking help from EVPN. How EVPN knows? EVPN uses the routing table. Routing table says who is connected where. I told you this environment is a layer 3 environment. It's a layer 3 environment. This is layer 3. So by referring into the routing engine only drives the routing table. How routing engine derives the routing table? With the help of some IGP protocol, OSPF or ISIS. So we run OSPF or ISIS within this red boundary. Within this fabric, we run some protocol using which the routing table knows the location of other VTAPs. So using that reachability which the routing table provides, the forwarding table will be built. The egress interface of the VXLAN VTAP interface is determined. So in short, if I want to say the data plane, which is a VXLAN, refers the control plane, which is EVPN, and populates the VXLAN forwarding table with all the destination. So forwarding table is derived, the VXLAN forwarding table is derived with the help of the control plane. The control plane make use of the routing table engine. EVPN, which is nothing but BGP's, one of the flavor of BGP's EVPN. So with that EVPN, the routing engine tells who is connected where. You see, the next hop destination is derived from a control plane. Let me make it very simple for you now. The MAC address of this guy, let's say AAA, is learned by this VTAP. As soon as it learns, it will advertise it to this VTAP. So this VTAP now knows that AAA MAC address with IP address 10.0.0.1 is VTAP 1. So this leaf knows the location of 10.0.0.1 AAA. Likewise, the MAC address of this 10.0.0.2 is advertised. So this VTAP knows that 10.0.0.1 AAA is local, 10.0.0.2 BBB is VTAP 2. Is VTAP 2. I'm just writing VTAP 2. It's an IP address of the leaf. How to reach that IP address? Your routing table will give you. So the control plane, the transport path, is determined by the control plane is determined by EVPN. Which MAC address is connected to which leaf is known to the leaves through EVPN. Reachability between the leaf is provided by some OSPF or some other IGP protocol inside this fabric between the leaf and spine. So EVPN is not the only option to populate the VXLAN forwarding table. You also have MPLS, I told you. Now let's go back to the document which I shared with you. Have you all gone through this document? If not, don't worry. I'm going to take you step by step. See, data plane. When I say data plane, it is VXLAN. Type of data plane traffic in VXLAN. Number one, known unicast traffic. What does that mean? You know who is connected where. You know the destination. You know that BBB is connected to VTAP2. In that scenario, what happens? I have a nice picture. Instead of me drawing here, let me show you down. See this nice picture. Host A is talking to host B. They all belong to same VLAN. Host A want to talk to host B. This is the IP address of host A. This is the MAC address of host A. This is the IP address of host B. This is the MAC address of host B. They want to communicate. And they are connected to a leaf in data center. Leaf. And this will be spine. In normal service provider, this may be an internet cloud. Whatever, whether it is service provider or data center, concept is same. You see the packet from host A goes with a source MAC address of A and destination MAC address of the original destination B. If you don't have VXLAN, the destination MAC address won't be host B. The destination MAC address will be VTAP. But because you have a tunnel, layer 2 tunnel, host A and host B feels as if they are connected to same layer 2 switch. They feel that they are connected to same layer 2 switch. So here they can send the ARP, the learn MAC address. Using the original destination MAC address, the packet is generated and it is sent. Now it goes to the leaf switch. VTAP1 knows the location of MAC B. Where is MAC B? MAC B is in VTAP2. So what it does is it puts the IP address of VTAP2 and source IP address of VTAP1 and source MAC address of VTAP1 and destination MAC address of the next hop, the spine. So the packets are going to be now routed only based on this upper layer. This is the original layer, you see. It is same like this one. No change inside layer. Inside layer is just encapsulated with this VXLAN. It is just encapsulated by this VXLAN header. I told you VXLAN uses UDP. '4789 port number. This is VXLAN ID 10. And this is what going to be used for moving the packet from here to here. Once the packet reaches this IP4, this gets removed, and by looking into the MAC address, the packet is delivered to the destination. See, somewhere around 50 to 52 bytes of overhead. Additional fields of 52 bytes, 50 to 52 bytes gets added to each packet. So VXLAN is kind of VPN where encapsulation and decapsulation happens between the VTAPs. One VTAP will encapsulate, the other VTAP will decapsulate. Now how? Again, the same question, how this knows that I need to use IP4, how it knows that I need to deliver the packet to this destination? It is because of BGP EVPN. Through BGP, this guy told already to VTAP1 that I am the owner of MAC B. So VTAP1 knows that to go to MAC B, I need to send the packet to IP4, which is VTAP2. Likewise, this will know that MAC A I need to send the traffic to IP1. This is what EVPN provides. The control plane. Who is connected where? Which MAC address is connected to which IP address of the leaf is learned and distributed through BGP called EVPN. You can also use MPLS instead of EVPN. Now let's go back to our presentation. Now you read this paragraph, it will be making sense for you. When VXLAN is configured, the switch forwards the traffic differently depending on the destination MAC address. So, if the source and destination MAC addresses are learned on the same switch, same VLAN, the switch will forward the traffic locally without VXLAN encapsulation. Do you agree? Do you agree with the point that I have highlighted? Read and let me know.